All right, guys, here in Chapter 4, we're going to move on to quadratic functions. And in 4.1, we're going to focus on vertex form and talk a little bit about domain and range. So to start here, just some basic quadratics information. A parabola is a graph of a quadratic function. As you might remember from Algebra 1, a parabola is a U-shaped graph. And this is what the parent function, f of x equals x squared, would look like. So I'm starting at 0, 0, and going from there. Vertex form of a parabola or a quadratic function is f of x equals a times x minus h squared plus k. And what you might notice is that vertex form of a quadratic is almost identical to general form of an absolute value. Really, the only thing that changed here is that instead of x minus h in absolute values, it's x minus h in parentheses and it's squared. So the important thing or piece of information that you'll get from vertex form is the vertex of your graph. So my vertex, similar again to how I look at the vertex of an absolute value graph, is going to be that hk value. And remember again here, whatever I see as my h value, how it's plugged into that form, the sign will be changed, and then I keep that sign for the y value. And then I also will call this vertex either my max or my min. So if I have a graph where that vertex is that low point of the graph, I call that a min value. And if I have something that looks like this, where my vertex is the high point of the graph, I'm going to call that a maximum value. Another new thing that we're going to talk about here going into quadratics is the axis of symmetry. So the axis of symmetry is a vertical line that cuts through the middle of your parabola. It's always going to be the x-coordinate of your vertex. And that's going to cut your parabola in half symmetrically. So let's talk about graphing a quadratic function. So whenever you graph a quadratic, what I'll focus on for any test or quiz is that you graph the vertex correctly and that you have the general U shape somewhat on the right track. So you'll want to plot at least 2 points on either side. This is going to be a little bit different than an absolute value in the sense that when you go on either side of the vertex, this isn't a linear equation anymore as there's a curve. So plotting 2 points won't necessarily be enough here because it's not a straight path. So again, you'll want to end up plotting 5 total points here, vertex, and then 2 on either side. So let's start here. Let's graph the first one by hand just to see how we could do it. In the next example, we'll go from the calculator. Here I have f of x equals 1/2 x squared. So if I have my table, I'd first want to plot my vertex. Here that would be 0, 0. And let's start by just going to the right of my graph, and then I'll graph to the left of it. So to see where I am when x is 1, I'll plug that in, and I get 0.5, and I'll plot that. To go to the other side, -1, it should mirror the same thing. And just to check when I plug that in, 1/2 times -1 squared, -1 squared turns into +1, so I also get 0.5. If I want to go one more to the right, I'll go for 2. 1/2 times 2 squared will give me 2, so I'll plot that. And then for -2, if I plugged it in, will give me the same thing. Now I have 5 coordinates plotted. I can connect my dots, and that'll be my graph. For our next example, let's look at how to do this in the calculator. Here I have f of x equals 3 times x minus 4 squared minus 2. So by hand, just by looking at this, you'll want to be able to know how to look at this and know what the vertex is to start out. Here, my vertex would be 4, -2. And now from here, let's let the calculator do the work. So when I turn on my calculator, I'll press y equals. I'm going to enter in my function. Again, I want to get in the habit of pressing zoom 6 or zoom standard just because I don't know what I graphed before. I want to make sure my XY axis isn't all goofed up or anything. And then when I press graph, my parabola will appear. What I like to do from here, in class we can go over how to look at this in a table. I always like to just press trace. When I do that, this will come up. And then I can type in any number for my x-coordinate, and then it'll tell me what the y-coordinate is. So let's start out at 4. So if I type in 4, press enter, I do see, in fact, that my vertex there is 4, -2. And now if I want to see where I am 1 point to the left, I'll type 3, press enter, and I see that I'm at 3, 1. So I'll plot that. Then if I want to go one more over to the left, I can type in 2, press enter, I see I'm at 2, 10. I'll plot that. And then from here, I could type in 5 and 6 by hand to see where those coordinates are, but know that parabolas are always symmetrical, so I could really just plot the points mirrored on the other side like that. I'll graph it, and I'm done. And another thing to notice here, just kind of tying in functions and transformations, this is changed from the parent function. It's shifted 4 units to the right and 2 units down. And as we can kind of notice here, this parabola looks kind of stretched out as my a value is 3. So since that a value is greater than 1, it kind of looks like if I had 2 hands on the top and bottom of that graph, and it looks like I kind of stretched it a little bit going up and down. The last thing that we're going to talk about in this video is domain and range. Domain is all possible x values for a function, and range is all possible y values. A lot of these parabolas will follow a very similar pattern. So let's take a look at that example that we had just done. F of x equals 3 times x minus 4 squared minus 2. So domain, again, is all possible x values that I could plug into this graph. Here, I really could go forever in either way, left or right on this graph. So for pretty much all quadratic functions, my domain will be negative infinity to positive infinity. Notice that my parentheses are open brackets because whenever I have an infinity, that's technically meaning I'm going on for forever, so that bracket can't be closed. They have to be open. My range, on the other hand, does kind of have one stipulation to it. So my range, I bottom out here at -2, and then I can go up for forever. So my range is going to be -2 to infinity. And notice that I start there at that -2 with the closed bracket because my graph definitively ends or can't go any lower than -2. Meanwhile, going up to forever and infinity, that's never really going to end, so that has to be an open bracket.